Hi, my name's Kevin, and today we're going to work on a topic that many students in CS have a problem with, and that's recursion. So let's get right into it. So what exactly is recursion? Recursion is the idea that a function can call itself, and let's say, before we learn recursion, we have in the main, you can have a call to a function that prints something out, for example. But with recursion, you can have a method call itself to create a loop of method calls. And if it's not infinite recursion, which I will touch upon what that exactly is in a second, each method call should make the problem simpler. So what you want to do is you want to move towards something that's known as the base case in order to stop your recursion, because if you don't have a base case, then your recursion is going to go on forever. And we must have a condition that leads to the method no longer calling itself again. That's called the base case, which I will be touching upon in a second. So let's write, sorry about that, but let's write our recursive method. This for later, but we have, let's say we have a method called recurse that prints out CS rocks, and you can call that normally in the main. Yeah, but we can call that in the main, and what it should do is it should print out CS rocks. But if you put in a call to itself in the method recurse, you'll have something very interesting, and that's called infinite recursion. So in this case, you call recurse, it prints out CS rocks. You call recurse from recurse, it prints out CS rocks. You call recurse again from recurse, and it prints out CS rocks. So in this case, you can pretty much get the idea. It's going to be infinite recursion until your computer crashes. So what exactly is the point of recursion other than crashing your computer? Well, it can be used to solve some problems, and let's go for a very basic one, and one that everyone knows from math class, and that's factorial. So let's have a method called factorial, which takes in an integer a. And the first thing you want to do when you're writing a recursive method is to first think of your base case. So pretty much you want to think of what's the simplest, most constant way to represent your problem. And in this case, the factorial of 1 will always be 1, and that's something that's always constant to factorial, and that's how you want to think about how to create your base case. So in this case, if a equals 1, you can return 1, because the factorial of 1 will always be 1, and this here is your base case, and this will allow your recursion to end, and without it, you're going to have what we just had, infinite recursion. So if a does not equal 1, you can return a times the factorial of a minus 1. So let's say you have the factorial of 5. The factorial of 5 can be represented as 5 times the factorial of 4. And that's exactly what we've done here. The factorial of 5 will call 5 times the factorial of a minus 1, 5 minus 1, the factorial of 4. Because the factorial of 5 equals 5 times 4 times 3 times 2 times 1. The factorial of 4 is 4 times 3 times 2 times 1 times 5. That equals the factorial of 5. And the reason we have done the problem like this is because at each recursive call, you're subtracting a, in this case 5, by 1, which will be moving you closer and closer to your base case, which will then end your recursive problem there. So the factorial of 5 should print out 120. So let's see how exactly this works out logically, because it's kind of a lot to take in at one time. So let's first draw here a data stack, which is just a representation of how the computer works out this problem, and it's just an easier way for us to figure out the answer. And this recursive call is linear, which means that in the return statement there's only one recursive call. There's something called tree recursion, which has 2 or more recursive calls in the return statement, but that's for another time. So let's go for our problem, the factorial of 5. So you call the factorial of 5. If a equals 1, you return 1. It doesn't, so you return a times the factorial of a minus 1, which is 4. So when you return 5 times the factorial of 5 times the factorial of 4, your computer is going to call the factorial of 4 because it doesn't know what it is, and it's going to call it the factorial of 4. The factorial of 4 is going to return a times the factorial of a minus 1. 4 minus 1 is 3. So you kind of get the gist of how you move up your stack here, and you're moving closer and closer to a being 1, which is your base case, and the way this recursion will end. So when you get to the factorial of 2, you get 2 times the factorial of 1, and then you get the factorial of 1. So you look here, factorial of 1, if a equals 1, it does, you can return 1. And that's exactly what the factorial of 1 does, it returns 1. So we know that the factorial of 1 returns 1. The factorial of 2 is equal to 2 times the factorial of 1. Well, right here we figured out that the factorial of 1 returns 1, so the factorial of 2 returns 2. The factorial of 3 is 3 times the factorial of 2. The factorial of 2 we figured out returns 2, so the factorial of 3 is 3 times 2, which equals 6. The factorial of 3 equals 6. The factorial of 4 equals 24. And the factorial of 5, our problem, is equal to 5 times the factorial of 4. The factorial of 4, now is 24. So the factorial of 5 equals 120.